Please meet Sloan Holliday, the lead fire developer for Optum Health, with a presentation today on lessons learned with fire paging and with plain server, facade, fire servers, and load balance systems. Take it away, Sloan.
Thank you. My name is Sloan Holliday. I am a lead fire developer at Optum. And, you're here because we have 15 minutes, which will be a little bit of a lightning round to go over some of the lessons learned that we've encountered dealing with some fire paging issues. Here's the basic agenda. And again, questions at the end, please, because this is a very short-term time to go over our agenda. Okay, so let's get going. Basic anatomy, what I did is whenever I'm learning fire, I try to go out to the publicly available sites and kind of see what's going. That's a good little rule of thumb. And I'm going to show the responses to these. Bonk, our friends at Aegis, and of course, happyfire.org, the reference implementations here. And when we do a paging request, we get this response back, and here's what Bonk's looks like. Emphasis here, oops, I can't click on it. Emphasis here on the total, 194, and there's usually a self link and a next link. And pay attention here to the URL. You see the word skip. I'll show a little bit of a difference there. I have this icon here, skip. That's a very .NET Core type of word, a link word, because Bonk is written in that technology. If we look at the Aegis response, they have a more simple paging, and we'll go with that in detail in a minute. Again, this self and this next, kind of optional that I observed was the first and the last. Not everybody includes that. And then we'll hit the one, and this is the code base that we're using, coding against, of course, Hapi. And again, this search set, I have this self link and I have this next link. And then we have this kind of get pages UID. So I'll put them all here together so you can kind of see them next to each other. The thing I wanted to emphasize here is that in the standard, the relation, next, and the URL are part of the standard. The value of the URL is up to the implementation. It just has to work. And so that was the highlight here. So you can see that each flavor is kind of doing just a little bit of different. We got the .NET type world here. We've got this. We're going to go in detail on this Happy Fire thing in just a little bit. And then the Aegis has a more simple, this is kind of what you see like on our standard REST API. Okay. So in general, fire server as a facade observations, we're going to breeze through the first 10 slides and slow down on the back half. This idea of the total count becomes very important. And if you look over here, I have the HL7 definition. Technically, it's optional because it's 0 to 1, but this gives us the overall and gives us clues as to how many pages that we're going to encounter. All right. And so my metaphor that I came up with is when you're dealing with the count, when you hit that first page, you almost need to have these two operations on your plain server or your facade. You need to say select count as accurate overall count. Obviously it may not be a database, it may be a backend REST service that you're dealing with, but whatever, this functionality kind of has to exist. An accurate overall count, where, and whatever filters that come in. And then you'll have this second type of give me page one and the row count, or the 10 rows in this example, from the organization where, with that same where criteria. So this became very important when we were doing the implementations. We had to actually contract with some of our backend systems to provide this because a lot of them never had that need before. They would just, page to us on demand. Okay. Another observation, how long does paging last? We were worried initially that like fire logical IDs that have to kind of be forever. We thought, does the paging have to be forever? We put that question out there on the fire chat, and super Graham himself replied, and he said, it's at our discretion, 30 minutes. If he replies with an answer, enough said, it's done. We set ours to 60 minutes, but that gives you an idea how the paging, up to the discretion of the server. Something else to pay attention to is what are your defaults and your max counts. If you give no value, what do you default to? 10, 50, 100, 1,000? And if someone tries to say, hey, I'm just going to give you the biggest value integer max or long max that I can, what would be your maximum count? And typical to HL7 with its lenient policy, you'll usually rewrite this down to your max instead of trying to fail the request. Okay, and now we'll jump into some Hapi Fire observations and kind of something custom that we came up with sharing the idea. So shifting gears, if you go out to the Hapi Fire observations documentation, the paging providers and the documentation says a server must have an IPaging provider. And the word must here, I had a question mark that, and if James is there, he can tell us later. But what I observed was something a little different from the documentation. The short version is that if you do not set a specific paging provider or you set it to null, it will fall back on this more simple type of REST service paging, where as you move through the pages, these variables will just increase. And there's nothing wrong with implementing it like that. Also notice that the Fire resource is in this URL. If you do set the paging provider, you start getting links. And I made the note down here that the Hapi Fire R4 implementation, the public available, is using this annotation as well. They're probably backed by a full Fire server data store, whereas we're here talking about plain server Façade. So load balance issues, if you get into the documentation of the Hapi Fire, you'll see a couple of the implementations that the default gives you. Now, the emphasis here is that the paging providers use a store resource list between incoming calls. We have a little bit of a play on this and a caveat I'll go over in a second. But whenever you need to store the incoming calls, you have to be able to persist something, some kind of arguments to somewhere, some kind of Redis cache or relational database. But the big problem that we hit was this something must be serializable. For me to put something in Redis, I have to have it serializable. And so, oops. Okay, it actually went to the URL. Okay, so load balance issues. One of the things that we started with, when we were first getting started, is this memory. Well, as the name implies, when it's attached to just the server in memory, if you have a load balance behind 3 VMs or 4 pods in a Kubernetes setup, you have a problem because that'll only be cached on that machine. When the next link comes in, you may lose that. And obviously, there's some sticky things out there, but that's more of a workaround versus, kind of a pure implementation. I started down this road, and I am not omniscient. I am not James. But when I tried to use this one, I hit some issues. It looked promising, but here's my where's Waldo icon. And anytime I get into Java annotation-based dependency injection, it starts leading you down to a where's Waldo world. Well, where's this one? Well, where's that one? Well, where's this one? I did follow this one out to kind of a maximum. And eventually I got to the point I'm like, well, this is overbearing. I am not omniscient. I don't know if there was a way to get that to work. There probably was, but I stopped because I entered this where's Waldo world. Okay, so what did we come up with? We did load balance, and this is the alternate idea, and we came up, fortunately, everything's written to an interface, so you can write your own. So we wrote a custom iBundle provider and a custom IPaging provider. These are Hapi objects. They are documented. And so what was our motivation? And here I got the little thinking icon. And the why we did this pause here a second and read this. There is a difference between caching the search criteria versus caching the results. And we did not want to be responsible for having a Redis cache full of PHI data. You know, one of the things about the world that we're living in is we've got patient records, very sensitive data. If we started putting that in either a relational database that we flushed or into Redis, you know, with the timeout, it becomes a place that you have to secure. And, you know, we went down this road of like, well, can we solve it a different way? And what we came up with, and I'll go back here to emphasize that we decided to cache the search criteria instead of the results. So if you go out to the Hapi Fhir website, some of their simple implementations, if you look for patient family name of Smith, and it gave you 6,700 results or whatever, the simple implementations say, hey, put all of those 6,700 rows into memory or into a cache and come back and deal with them later. We were trying to we were trying to pay as you go and not overburden the first request trying to get like all those 6,700 rows. So we came up with this idea of an IOC pay as you go. And I'll pause here a second and go over this a little bit more slowly. This is a custom bundle provider. It implements serializable. This is a Hapi object right here, the iBundle provider. So when I create this object, this is what I will actually persist to the cache. I set the overall size. With the patient example I gave, 6,700. This is a T object. T extends serializable. That's important to let it, so it goes into Redis. And it's this generic that represents the filters. So with my patient example, maybe I capture family name, given names, and date of birth. That is decoupled from the Hapi framework. That is my own little POJO that represents that. Now, we've got the Spring context here. And this must be transient, because what I found was if you try to pull this off and, you know, you had some kind of manager or Java calls it service or, you know, Java repo data layer, it would start trying to serialize that entire IOC graph. And that was the tension point that we hit. So what we did is we made this transient, and when it resurrects or comes back, we set it through a setter down here, but it's transient in the fact that transient says don't serialize me. Then we have a string that represents the IOC type name. Java developers like to call this the Spring Bean name, or Spring Java developers. And so when that call comes back in to get the resources, we go into the IOC and we fish out that item from the IOC. Throws the sonar friendly, you know, it doesn't say, hey, this is dangerous, but we know what we're pulling out. When we pull it out, we put that thing behind an interface, and over here's the interface. And so it gives you a list of base resources. That's the parent of patient, allergy, intolerance, et cetera, et cetera. There's our inner args. And then we cast that. We make sure I don't have any of the error checking in here. This is the you know, basic example, Hapi path. We cast that, and then we execute this method that we know exists on this, and then we return the items. So this was a way that we were able to not have to serialize the entire object graph, but still be able now to pay as we go. So once we pull that out and it calls this, the implementation of this for a specific Fhir resource, patient, allergy, intolerance, observation, whatever, would have the smarts in it that said, hey, now go to the backend system and get page 2, you know, rows 21 through 30, that kind of thing. sorry, 21 through 40, if that was page 2 in that example. Okay. And so 5 minutes remaining. To close this out, we have a paging provider, and this is also necessary. This is what will set the serializable on the iBundle provider. So this is the sibling of the other thing, the bundle provider that we needed to put in. So I'll have this available as the slide deck. I couldn't share the code, but it gives you all the clues here. This is the responsibility to save. This is the thing that saves it off to Redis and pulls it out of Redis on demand. And of course, here was the trick. The thing that you put into Redis had to be serializable, which was the previous thing. Okay. And so let's see, 5 minutes remaining. Time space continuum issues. This is an in general rest. If you have heavy writes or deletes, that page can move on you. This is a total new idea. I've shifted gears on you. One idea is that when you get that first request, this is if you have a heavy write or delete system. You don't have to do this. There was one Fhir resource that we found that this was happening. And so on that first request, what we did is we actually went and grabbed all the surrogate keys from the backend system, and we saved this. And so when that second page comes in, we would say, okay, backend system, I'm being, oops, that was not good, can't click. Items, page 2, 11 through 20, we would go to the backend system and retrieve these by surrogate ID. It's kind of a where exists thing in a REST world. Okay, time for a demo, didn't think so. But I just wanted to show you here really quickly that the table and the database that we are saving the IOC, this is the bean name, and this is the serializable object. Obviously, it's binary encoded there. We happen to save the resource just for kicks. And this is the unique ID, GUID, UAU ID, that is the get pages ID. And so when the request comes in, it comes to here, it reads out the IOC name, and it reads out the arguments that we saved, and it's able to wire everything up and call that page 2 on demand, pay as you go. Okay. All right. So I got through there in blazing speed. Guess we can open it up for questions now.
So Sloan, I'm guessing with the detail of your presentation that it's probably hard to write something in the Q&A in Whova. If you'd like, I can unmute the participants or allow them to unmute themselves to ask.
They can go ahead and unmute. That'd be fine. One note, the monitor that I'm sharing for the presentation is above my head. That's why it looks like I'm looking out to space all the time. All right, does anybody have a question when we get shared?
Not seeing any. Did you want to try to do a demo for a couple of minutes?
Yeah, okay. So let's see, if I stop sharing this, we can go to the Postman and we can go to the database. And so to show you here, if I run this, this is now empty. So this is the table that I happen to be saving all of this stuff. And so if I come to my example here, I can show you the simple. And so if I click this, if you look at the next link, and this is when I do not set the IPaging provider in the Hapi Fhir setup. The next link is very simple. You get the resource and it comes in kind of like a typical REST controller type of situation. But if I come in with the IOC paging provider, and again, you can always use the Hapi ones, or we have implemented a custom one. This will give you the get pages UID. And you see here, I got 5747. And now if I go back to our database, we actually do it in Redis. I made a database to make it a little bit easier to see. you'll see that I have this GUID in here that starts out with 5747, has the arguments, which included the family name of Smith, I believe, and you know, the rest of the metadata that we serve right there. So, you know, did have it working. And so if I take this GUID, if I can get it there, actually, I will take it from here because I have that much confidence in it. And I come down here to the next page and I paste this GUID in and I hit send. I should get page 2. And my offset was 30. So you can see that by an offset of 30 and count of 30, this is page 2. You get used to those count and offset numbers when you deal with the Hapi framework. But yeah, nothing but Smiths in here. So anyway, yeah, we have a working implementation.
Thank you, Sloan. Really appreciate your presentation today. Again, if you have any further questions, please put them in the Q&A on Whova that will persist after the session. And we've asked Sloan to go out there and moderate any questions submitted after the fact. Please also in Whova rate the session and have a great day.